Isomerism and nomenclature. First of all, nomenclature was discussed in detail in the previous chapter. So that means you should have an idea as to how you can name the compounds even now. If you remember, we talked about isomerism as well in the previous chapter. So isomers are compounds which have the same molecular formula, but they vary in terms of structures. So obviously, alkanes can show the property of isomerism. Now, methane and ethane and propane. Let's draw their structures. So, this is methane. No matter where I try changing the orient or like changing the location of the hydrogen atoms, it's going to be the same, right? So, methane does not show isomerism. Next, let's move on to ethane. Now, okay, now what can we do? Okay, let's do one thing. Let's replace this hydrogen atom with this carbon atom. Okay, and we basically what we'll be doing is we'll be exchanging these two. So, let's do that. Do you see any change in terms of the structure except for the fact that it's probably, it's horizontal, this is vertical. So there's no change. So ethane is also not able to show isomerism. Next, let's move on to propane. So propane has 3 carbon atoms, right? So this is propane. Okay, now if I'm thinking if I make sense, let's do one thing. Even if you try and change the arrangement of the carbon atoms, that you only have 3, okay? So it's either going to be this or this, which is basically this in an L-shaped format. So methane, ethane and propane, these 3 do not show isomerism. It's only from the 4th one in the series, that is butane, that we start talking about isomerism. So these 3 are not going to show us isomerism. Okay. So let's start with butane. Now butane's formula is C4H, 4 2s are 8 plus 2, that's 10. Pause the video right now and try drawing the various structures. So let's start with the easiest one of the lot. See? So this is going to be a straight chain. So I can just fill in the hydrogens after. So this is a straight chain butane. It's a butane. But that's not all that we can do, right? What we can do, we can take this entire group or take this carbon atom and just shift it to this side. So we will be getting a propane with another carbon, a methyl group attached to it. But notice the number of hydrogen atoms are going to stay the same. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You have 10 hydrogen atoms and 4 carbon atoms. But the IUPAC name is different. Here it is butane, right? And whereas here it's going to be 2-methyl propane. I'll just write it here. 2-methyl propane. Because at the second carbon atom, you have a methyl group attached to it. This one is called as butane. So their common names are also going to be different. This is N-butane, whereas this is going to be isobutane. The boiling point of both of these structures are going to differ. We will talk about the reason for all of this in detail when we talk about the physical properties of alkanes. But here the boiling point of butane is 273 Kelvin, whereas boiling point of 2-methyl butane is 2-methyl propane is 261 Kelvin. So there is a difference in terms of boiling points. Next, pentane. pause again right now if you would like to draw the structures on your own. We are just modifying the order, or rather we're changing up the way we write the carbon chain and then filling in the hydrogen atoms. So pentane's formula is going to be C5H, 5 2s are 10 plus 2, that's 12. CnH2n plus 2. So C5 can be a straight chain. So this is the easiest. And fill in the hydrogen atoms. So this is the C5H12. And this is pentane. Now, what can we do? We can obviously change in the order, right? So we can shift it to a 5-membered chain. From a 5-membered, we can shift it to a 4-membered. So that will give us a butane chain with a methyl group attached, right? So fill in the hydrogens again. If you still find it difficult, remember the valency of carbon is going to be 4. So we're just replacing the 4 valencies with hydrogen atoms. So here you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it follows the C5H12 formula. But the name of this, the IUPAC name of this is going to be 1, 2. Second carbon atom has a methyl group attached to it. So it is a 2-methyl methane, ethane, propane, butane. Butane. The third way we can write it, obviously, is going to be what? We're going to be shifting one of this to this. So here it will shift from a 4-membered to a 3-membered chain. So here it's going to be, I'm not opening up the structure, but yeah. So CH3 and a CH3. So 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 hydrogen atoms. So it is still following the C5H12 formula. But the name is going to be, the chain length is 3, which means it's a propane. And at the second carbon atom, you have 2 methyl groups attached to it, which means the name is going to become 2,2 dimethyl propane. By now, you should know how to write the IUPAC names because you had already learned about this in detail in the previous chapter. If you still find it difficult, I suggest you go back to that one, recap on that and come back here. Okay, so the boiling points are obviously going to be different in case of pentane, methyl butane and dimethyl propane. So the boiling points are 309 Kelvin for this one. And this is going to be 301. Oh, you can't see it, I'm sorry. So for this, it's going to be 301 Kelvin. And in this case, it's going to be 282.5 Kelvin. Now, think about how they're different and think about what are the forces that govern the boiling points of a particular compound. And maybe you'll be able to come up with an answer. Do think about it. We will be discussing that when we talk about physical properties. But there might be something that you're looking at it and you might be able to figure it out. If you don't, it's completely fine. We will be discussing about it when we talk about the physical properties. So the above structures, they are the isomers of butane and pentane. And each of these cases, if you notice, there is a difference in structure. And that's why they're called as structural isomers. Not only that, if you notice, there is a difference in terms of chain length. So they're called as chain isomers. And so based on the number of carbon atoms, as we know, we have 3 different types of carbon atoms. One is going to be primary. I'll just write that down here. So let me just draw the structure of butane. So that's going to be a CH. Okay. Butane is C4 carbons and you have hydrogens. So this is a straight chain butane. So here we have two different types of carbon atoms. This carbon atom is only bound, this is only bound to another carbon atom. Okay, this as well as this. Both of these carbon atoms are just bound to one other carbon atom. So these atoms are called as primary carbon atoms. Primary. On the other hand, this one, these two, that is this as well as this, these are bound to two carbon atoms. So you have 1 and 2 in case of this, and 1 and 2 in case of this carbon atom. So this carbon atom is called as a secondary carbon atom. And so here what I just did was replace the hydrogen with a carbon, right? So when we talk about this carbon, this is bound to 1, 2 and 3 carbons. So it becomes a tertiary carbon atom. Whereas if I replace this this hydrogen with a CH3, then this becomes a quaternary carbon atom. To make things even more clearer, let's do one thing. CH3 I am not asking you to name this compound. Take a moment and think about what, again, I'm not numbering these in terms of their, the nomenclature. I'm just assigning normal common numbers for our understanding. This is probably not even the longest chain, but I'm using this for us to identify the carbon atoms. So let me just number it. So you have the first one, second, third, fourth, and fifth. Then we'll just number these as well, 6, 7, 8. Yeah, I am not numbering this in terms of the IUPAC nomenclature. Pause the video right now and try and figure out what each type of carbon atom is going to be. So let's look at the first one. The first carbon atom is a primary because it is bound to one another carbon atom. The second one is bound to 1, 2, 3 and 4 carbon atoms, which means it's a quaternary carbon atom. Next, the third one, or wait, one second. Primary, secondary, tertiary and quaternary. We told the first carbon is primary, the second carbon is quaternary. Next, let's look at the third one. 1, 2, 3. It's only bound to 3 other carbon atoms, making it a tertiary carbon atom. The fourth carbon, 1 and 2. It's only bound to 2 other carbon atoms, making it a secondary carbon atom. Next, the fifth one is again going to be a primary because it is just bound to this one carbon atom. Remember, notice 6, 7 and 8. All these three have CH3 and so they are primary again. So 6, 7 and 8. Or to make things even more clearer, in hydrocarbons, a primary is going to have 3 hydrogen atoms attached to it. A secondary is going to have 2 hydrogen atoms attached to it. A tertiary is going to have 1 hydrogen atom attached to it, and in case of a quaternary hydrocarbon, the carbon does not have any other hydrogen atoms attached to it. If you still find it a little complicated, open up the structures and then figure out the number of carbons that particular carbon atom is attached to. And the next thing is, as we go higher, the number of carbon atoms will increase, and so the isomerism or the number of isomers formed is going to increase. For example, our hexane is having 5 isomers, heptane has 9 isomers, and decane has up to 75 isomers. Imagine having to draw 75 isomers. Quite complicated. Anyways, so alkyl group, if you remember in the previous chapter, we told that you have methyl group attached and ethyl group attached. Basically has one hydrogen atom less than an alkane. So when you have an alkyl group attached, its general formula is going to be CnH2n. CnH2n minus, or rather plus 1. So this is the general formula for such alkyl groups attached to the alkane. Now there is a table that covers the nomenclature, and we'll be discussing about the table and talking about how we can write the structure from the name of a compound in the next video.